Solving trig equations part 2. So we're going to do a quick review of solving trig equations part 1. That's example 1. But so we're just making what we did before, just making it a little bit more complicated, adding more layers. Not to be mean, but to extend our understanding of trig. So solving sine of x equals -1/2. There's lots of ways to do that. There's a way to do it on your calc, which I never showed you guys. But to me, the easiest way is to understand it in terms of the unit circle. So sine equals a negative. So I'm going to use my check mark system. Where is sine negative? Well, sine is the same as y in the unit circle. So that's going to be those two quadrants. Which one of my special right triangles has a sine value or a y value of 1/2? If you look at the 30, that has a y value of 1/2. So sine of 30 is 1/2. Now I have to identify who are the 30-degree angles in quadrants 3 and 4. So I would have x equals, 7 pi over 6 in quadrant 3, or 11 pi over 6 in quadrant 4. All right, so that's the review, quick review. That's basically what we did in solving trig equations part 1. So we're going to always kind of try to get back to this. I mean, think about it in Algebra 1. Your goal was always to get to a spot that looked like this, something like 2x equals 18. That was always our goal, to get to a standard, or maybe even we take it one step further, 2x plus 4 equals 18. Once you got to this step, everybody knew how to finish it. You'd subtract 4 and then divide by 2. So if you could get your equation into this format, you could always solve it. Same idea here. We're trying to get to a spot where we can go to our unit circle with the check marks and the special right triangles. So solve secant of theta equals 2. Look, I don't think about secants and cosecants and cotangents. I always think about those as reciprocals of the big three, sine, cosine, and tangent. So the first thing I do when I see a secant problem is I reciprocal it into cosine. Secant is the same as the reciprocal of cosine. So I'm allowed to change secant into cosine as long as I reciprocal. So I reciprocaled secant into cosine. I can do that as long as I reciprocal 2 into 1/2. Put 2 over 1, flip it over. Now I've got an equation that fits into this category. Like I said, it was always our goal. So I can now go to the check marks. Where is cosine? First of all, it's positive. So where is cosine positive? Well. Check, check. Where is cosine 1/2? That's with a 60 degree. So I'm finding the 60 degrees that are in quadrants 1 and 4. So theta would be equal to pi over 3 or 5 pi over 3. If you're confused about this check mark thing, go back and watch I think it's 6.3 or 6.4, 6.3, I think. How to solve trig equations part 1. Example 3, cotangent of 5x equals the square root of 3. So look, whenever you're solving, you're always trying to take care of what's farthest away from x first. So this 5 is going to come into play, but I've got some work to do first. I've got to take care of the cotangent first. And just like we did with secant, when I've got one of the reciprocal trigs, the first thing I do is reciprocal them. Now look, when I reciprocal cotangent, that becomes tangent. I don't reciprocal the 5x because the 5x is inside of the function. It's not something that's going to get reciprocaled. The function cotangent gets reciprocaled into tangent. Now I need to reciprocal square root of 3. Well, I'm not going to show my work. I guess I could show my work for this. Square root of 3 over 1, then that would become 1 over square root of 3, and then I'd have to multiply by root 3 over root 3. Anyway, I know it's going to be square root 3 over 3. We've done so many of those. Okay, so now I'm at the spot. Who's still farthest away is tangent. So I've got to kill tangent with a check marks. Tangent is positive here and here. Okay, so tangent is positive there and there. Tangent is square root 3 over 3 for a 30 degree. Look at your unit circle if you don't believe me. You can find it on there. So at this point, we were done on these, but because I still have to get rid of that 5, I'm not done yet. So I now have the equation 5x equals, who's the 30 degree in this section? Pi over 6. Who's the 30 degree in this section? 7 pi over 6. So who's keeping x from being by himself is the 5. So we still need to divide off that 5. And I'm going to show you up above how that would work. So let's take pi over 6 and divide it by 5. Nobody in the world can divide a fraction. First of all, if you're going to divide a fraction, the other thing has to be a fraction. And nobody can divide by a fraction, so we flip and multiply instead. And what would we end up with? Multiply straight across, you'd get pi over 30. So essentially, what happens when you divide a fraction, it's kind of like switchy without the switchy back. So when I switch the 5 down here, I don't switch the 6 back up, and it ends up being pi over 30. So switch the 5 down there and then leave it. So I'm going to switch the 5 to the denominator. 5 times 6 ends up being 30. So I get pi over 6, or, my bad, pi over 30, or 7 pi over 30. What do you think? I think today, I don't think there's any that I'm going to leave you to work on your own. I think I'm going to have to do all of them. I'm going to just show you one of each type. I mean, notes would take 2 days if I did one and you did one. Your practice time is going to come in the homework. So let's start off. Let's start off thinking about this in terms of how we have always solved equations. Who's farthest away from x on the same side? So let's go with who's closest. It kind of feels like the squared is closest, but remember that squared is around the whole thing. So that squared really means this. So the closest thing is cosecant, then there's the squared, then there's the 3 connected by mult, then there's the 4 connected by subtract. So the farthest thing away is the minus 4. So I'm going to add that across. And then the next farthest thing is the 3. So I'm going to do both of those moves at once. So I now have cosecant squared of x equals bump over the 4, divide by the 3. All right, now who's keeping x from being by himself? The cosecant and the squared. But just up here, we showed you that squared is the furthest thing, is what's around everything. Remember, this really means cosecant of x squared. So I want to kill that squared with a square root. Square root is on fire. We don't need no water. We just need a plus or minus. All right, so the square root and the squared cancel each other out. And so I'm going to now try to square root 4 thirds. Well, what's the square root of 4? That's 2. What's the square root of 3? Well, that's the square root of 3. Now, I noticed that I've got a root on the bottom. That's something I probably would try to fix, except I had also noticed that I've got a reciprocal trig function. So my next move, I'm going to reciprocal this, which means I'm going to reciprocal this, which means my root won't be on the bottom anymore. So who's the reciprocal of cosecant? That's sine. What's the reciprocal of 2 over root 3? Would be root 3 over 2. And now I'm to the spot where I can do my check marks. Okay, this time sine is positive and or negative. So I'm going to do a check mark for all the places sine is positive there. Sine is negative there. So all 4 of those work. Sine is square root 3 over 2. So the 60-degree special right triangle has a sine value of square root 3 over 2. So I'm going to have 4 different answers. It's the 60 in every single quadrant. X equals pi over 3, or 2 pi over 3, or 4 pi over 3, or 5 pi over 3. All right, so solve cosine of x minus root 2 equals negative cosine of x. So this is our first one. If you notice, all these other ones just had one trig function. So there's two different scenarios where you can have multiple trig functions. You can have the situation where they're all the same, which is the one we like the best, or you can have the one where they're different. So we're going to talk about those in a second. When they're the same thing, we can just combine like terms. So if you're looking at this, you would say, all right, who's farthest away? Or sorry, I can't get rid of who's farthest away until I get these cosines together. Since they're both the same stuff, I can just add them together. So I'm going to add cosine of x, and I'm going to add cosine of x. What's cosine of x plus cosine of x? 2 cosine of x minus root 2 equals 0. All right, now I'm going to go back to this thought process of killing off who's farthest away from x first. So this is farthest away, this is next farthest away, so I'm going to do a double move. Cosine of x is equal to the square root of 2. Bump that over, then divide by 2. And that's one of my special right triangles, so I can now go to the check mark stage. Cosine is positive, check and check. Cosine is root 2 over 2 at the 45s. So my 45s would be x equals pi over 4 or 7 pi over 4. All right, so what do we do when those trig functions cannot be combined? And that's what we're looking at in this one here. So we're going to, all right, so I would recommend, usually you want most of our equations, we always want them to be equal to 0. So anytime I'm going to have to do something, usually when you don't have like terms, you're going to have to factor at some point. And usually when we factor, we're going to want a ZPP. So kind of your instinct should be get this thing equal to 0. So my first move is I'm going to subtract this to the other side. So I now have cotangent of x cosine of x subtract 2 cotangent of x equals 0. Now from here, you just have to see this, and lots of practice is what helps you see these. Do you see the move? Do you see the type of factoring that we're going to have to do in this case? Look at the left-hand side. My math voice is yelling. It's yelling factor out. This term has a cotangent. This term has a cotangent. So I can now factor out cotangent of x. That leaves behind cosine of x minus 2 equals 0. Now that we've factored out, we can do that good old move called ZPP. So now I can ZPP both sides. I feel like I just used that color. How about purple? ZPP. So I can now take each one of these and set them equal to 0. So cotangent of x equals 0, or cosine of x minus 2 equals 0. So let's try to solve this one first. Do we like cotangent? No, it's one of the reciprocal trigs. So we're going to reciprocal it into one of the regular ones. The reciprocal of cotangent is tangent. But the cost we have to pay there is we have to reciprocal this side. So what's the reciprocal of 0? Reciprocal of 0 is undefined. Now you might say, okay, well that means that there's no solutions. No, that's not true. You want to think about this in terms of what we know about tangent and what the number undefined really looks like. So what do you know about tangent? Well, we know it's sine over cosine. We also know that it's y over x. What do you know about undefined? Undefined is no good. So really what we're trying to do is we're trying to say, where are the places? I don't care what y is, but I need x to be 0. Where in the coordinate plane is x 0? X is 0 here, and x is 0 here. So those are locations in the unit circle. So x could equal, that's pi over 2, or 3 pi over 2. So I'm not going to box that in yet. I'm going to see what I get for this solution before I box anything in. So let's go ahead and finish this. So let's bump over 2. Cosine of x equals 2. So wait a minute. This is asking me where in the unit circle, when I draw my check marks, where would cosine be a length of 2? What's the largest cosine? Think of the graphing that we did at the end of unit 6. The highest cosine ever reaches is 1. The lowest it ever reaches is -1. It would never reach 2. So this part has no solutions. Now, I'm not going to box that in. That just means that this part of the equation doesn't have any solutions. It doesn't harm this part, these solutions that we found over here. So these are the only solutions that actually work. This was a dead end. When we ZPP'd that part, there's no numbers that would ever make this piece true, but it doesn't take away the fact that this would still be true. All right, and now the last one. These are really sneaky. This is, there's lots of ways to do these. The way I usually like to do it is I like to do a substitution. So like what I'm thinking of is I'm going to say, so I've got a cosine and I've got a cosine squared. I need to factor those. I can't combine them. It's like having an x and an x squared. The only way to finish that is to factor. Now what messes kids up is they don't like to factor with the cosines in there. You can do it. Instead of writing x and x when you write your parentheses, you're just going to write cosine x and cosine x. But another way you could do it is you could do a substitution. Let y equal cosine of x. So now 2 cosine squared becomes 2y squared. Plus cosine of x becomes y minus 1 equals 0. Now I have something that I can factor. Now, nobody asked me to solve anything for y, but what I've done is I've hidden the cosines. I've repackaged them as y's so that I have something that's much easier to factor. So remember how we factor. 2 times -1 is -2. Middle term goes in the middle. That'd be a +2 and a -1. So then this factors into, one of them is going to be a 2 and a y and a 1 and a 1, and I want a +1 and a -2. Now what? From here I ZPP. By the way, if you didn't remember how to factor this, go back and watch section 0.2, I think, or 0.1, 0.3. It's one of those first ones. You must know how to factor. It's just like common in this class or at this level of math. All right, ZPP this. So I would get 2y minus 1 equals 0, or y plus 1 equals 0. I would get y equals 1/2. I would get y equals -1. Now, nobody cares what y is. Y is something we chose to hide cosine as, just to make it easier to factor. So at the end, don't forget that you're going to have to actually put cosine back into your equation. Cosine of x equals 1/2. Cosine of x equals -1. And now we want to solve this using our unit circle. So where's cosine positive? Check, check. That would occur when we have a cosine would have to be a 60. So this has a solution of x equals pi over 3 or 5 pi over 3. And then let's see, is cosine ever -1? Yes. Cosine is -1 over here. That has an x value of -1. So that value would be pi. Okay, so just kind of step back and let's look at all these one more time. We reviewed how to just straight up solve a trig equation. Then we talked about how to handle when you have reciprocal trigs, reciprocal both sides. Then we talked about how to handle when you have a number in front of the x at the end. That just means at the very end, once you solve, just like pretend like it's not there, and then at the end, you need to divide out that number that's attached to the x. A couple of things to remember: when you square root, you have plus or minus, which means you're going to have more than just 2 solutions. And then we talked about the scenarios where there's more than one x. If you can combine like terms, combine them and then solve. If you can't combine like terms, I recommend getting it equal to 0 and then doing some kind of factoring. All right. The only way you're going to see this stuff is by practicing. So get in there and do it. Good luck.